Hey guys, welcome back. We're on April 9th. Today we're doing Chapter 7, Section 4. So earlier in the chapter we were talking about proportions with similar triangles, and now we're going to use proportional parts in triangles and then apply some parallel lines with them. So some new vocabulary is the mid-segment of a triangle, and the definition is a segment whose endpoints are the midpoints of two sides of the triangle. Kind of confusing just reading the words, but later in this section we'll talk about that a little more and show you what it looks like. So here's a theorem. It's a triangle proportionality theorem. Now we're given this triangle over here and we're told that this segment BE is parallel to this segment CD. And using that information we can show that the ratio of AB over BC, that long length over short length, will be proportional to AE over ED, so the long length over the short length again. And on the next slide, they're going to have the short length over the long length equals short over long, and that's okay too because they'll still be proportional. It doesn't matter if we have both shorts on top or both shorts on bottom, we'll have the same thing. So let's apply this. So we're given triangle RST. They give us some values going on. So if we apply this theorem, we could take SV over VR, so the short over long equals SU over UT. So we would have 3 over 8 equals X over 12. And they'll show that on the next slide. Okay, this is where we apply that cross products property. Go ahead and simplify this. So we get 36 equals 8X. Divide by 8, we get 4.5. So the value of X that we were trying to find, we get 4.5. All right, pause your video, try this one on your own. Okay, so we'll just set this up the same way that we did the last one. So we could do, we're looking at one side, so we have 4 over 10 and a half equals, all right, I took my short over my long, so I'm going to do the same thing. So I get 6 over X. Okay, apply the cross product properties, so I circle those, multiplying those together, set them equal to those. So in our next step down here, we get 10 and a half times 6 equals 4X. Okay, when I multiply 10 and a half by 6, I get 63 equals 4X. Now I need to divide 63 by 4, and I get 15.75. So the answer that you guys should have been getting at home is D. All right? So now this is just the converse of that theorem. Remember, when we're given a converse, it's like the original but backwards. So in this case, we're told that the proportion of each side and the parts are proportional. So then using that, we can prove that ED and AC are parallel segments. So let's apply that as well. Okay, so we're given triangle DEF. Here we have DH is 18, so I'll just write that in quick. HE is 36. Now DG is 1/2 of GF. So I'm just going to call GF X, and DG is 1/2 of X. Okay, now this one's kind of easy because we're given 1/2. That's a really familiar fraction. So X is this GF and DG is 1/2 of it. So if these were proportional, 18 would be 1/2 of 36, right? Well, that's true. 18 is half of 36. So since those proportions are equal, we can prove that the segments are parallel because this is proportional. Okay. Here's one for you guys to try as well at home. Okay, we have to determine if they are parallel or not. So we're given XY is 15, so here we have 15, WA is 18, AZ is 32. Okay. Am I missing something? Oh, YZ is 25. Okay, so we're going to set this up in a proportion to see if they are proportional. So I'm just going to say 18 over 32 equals, I'm going to put a little question mark because we don't know if they're equal or not, 15 over 25. Well, if we apply the cross product here, we should have 18 times 25 equals 32 times 15. Okay, well, if I do that quick over on my calculator here, we get 18 times 25. Here we get 450. And if we take 32 times 15, we get 480. Notice that these are not the same, so I'm going to say they're not equal. So since these segments are not proportional, no, these segments are not parallel. Okay? So here's that mid-segment theorem. Okay, so we talked about the definition earlier. Okay, so this is saying if J and K are midpoints of these sides, if you can see we have a single congruence mark here and a double congruence mark here. So they're not all congruent, they're just congruent to each other on this side, so we have the midpoints. Okay, then JK is parallel to FG. So this JK is parallel to FG, and JK is 1/2 of FG. So we'll apply that. Okay, so in the figure it says DE and EF are mid-segments of triangle ABC. We have to find AB. Okay, so AB is this long thing here. Okay, and we're given that they're mid-segments, so we want to use this ED, and it tells us that ED equals 5. So I'll jump to the next page. Using that theorem, ED is 1/2 of AB, so we're just going to substitute in that ED that was 5, multiply each side by 2, and we get that the length of AB is 10. Okay? Here's the same figure, but now we're trying to find FE. So here's FE. We know that that's 1/2 of BC, so we need to use that 18 that they give us. Okay? Since FE is 1/2 of BC, we can substitute that 18 in for BC, multiply that out, and so the length that we get for FE is 9. One last example here. Now we're looking at angles. Okay, so we're still given that DE and EF are mid-segments of triangle ABC. Now we have to find the measure of angle AFE. So I'm just going to write this X right here. Okay, so this is where we have to apply a little bit of thinking and apply some stuff that we know about parallel lines. So if this FE, if these are parallel, and this ED is parallel to AB, then this 87 will be alternate interior angles with this angle AFE. So over on the next page, they're going to talk us through that. The definition of congruence means that they're going to have equal measures. So we find that the measure of angle AFE is also 87. Okay, here's one for you guys to try at home. Pause your video, work this out. We're trying to find BC. So BC is here, okay? And since they're mid-segments, we're going to use this DF being 8. So if I know that DF is 1/2 of BC, we should be finding that BC is 16 because we just double it. Okay, now in this one, we're trying to find DE. Okay, so here's DE, and that will be 1/2 of this AC, which they tell us is 15. So if we take 1/2 of 15, we should be getting a 7.5 for the length of DE. All right, now this is where we're looking at the angles again. So we have to find the measure of angle AFD. So I'll just mark that in. AFD is this little angle in here. Nope, sorry. D here. Okay, so this DE is parallel to AC, and if we call this DF the transversal, then this 122 degree angle will be congruent to this angle AFD, so we should be getting D 122. Okay, now here's another corollary, not a theorem, but a corollary. We've talked about those a little bit. Okay, so we're told that if 3 or more parallel lines intersect 2 transversals, so here's our 3 parallel lines, we've got our 2 transversals, then they cut off the transversals proportionally. So if AB and BF and CG are all parallel, then AB, this segment, over BC, this segment, will be proportional to EF over FG. So let's apply that. Okay, so kind of a real life example here, we're talking about roads. So the figure shows the distances in between the city blocks. We have to find X. Well, using this theorem, we should be able to set it up that 13 over 26 is proportional to 16 over X, or vice versa. Okay, so they did 26 over 13 equals X over 16. Now you might be just looking at this and knowing that 13 is half of 26, so 16 must be half of X, but they might apply the cross product property. Go ahead and solve it out. Divide that 416 by 13 and make it 32. Like I said, you could just double this 16 and get the 32 for X. Okay, here's one for you guys to try. I don't know if you can see these numbers, so I'll just walk you through it. So here we're given Davis, Broad, and Main Streets are all parallel. So we can go ahead and mark in these as parallel lines. Okay, this is probably way too small, but this number here is 24, so we have 24 over this number here is 8, and we'll set that equal to this number here is 15 over X, and we're trying to find what X is. Okay, now I'm looking at this, I don't want to apply the cross product property because these are pretty nice numbers that we're dealing with. 24 divided by 8 is 3, so 15 divided by X being 3, we must find X to be 5, because that would make those proportional. Okay, I think this is one last thing that we're going to go over. Kind of a long day today, lots of stuff to cover. If 3 or more parallel lines cut off congruent segments on one transversal, then they also cut off congruent segments on every transversal. So this AB and BC here, those are congruent segments. So that's telling us that this other transversal, EF and FG, will also be congruent. Not congruent to AB and BC, but congruent to each other. So let's apply that now. So we have to find X and Y. Okay, right away, we're told that these two segments are congruent. So we can set those equal to each other to find X really easily. So we set 3x minus 7 equal to x plus 5. We're going to combine like terms. We get 2x equals 12, so then x will equal 6. Now, using that theorem that we just talked about, if these two segments are congruent, then these two segments will also be congruent. So to find y, using that theorem, we're going to set them equal to each other. And that's what this page is talking about. Okay, so we set these equal to each other. Again, combine like terms, we get 3y equals 6. So y equals 2. So just down at the bottom, we're saying that x equals 6 and y equals 2 because that's what they asked us to find. Okay, one for you guys to try. Again, probably too small for you guys to see if you're looking on your phone or your computer. So here we're given 4a minus 6 equals 4a minus 5 equals 3a plus 6. So I'll do that down here. So I have 4a minus 5. They give us the congruence mark, so we know that they're equal. Equals 3a plus 6. Okay, I'm going to subtract this 3a over, add the 5 over, so I get a equals 11. just looking at our options, we automatically know, well, C is the only option with 11, so that's going to be our answer. Over here on this side, we know that this segment is also congruent to that segment. So here we have 3b equals 5/3 b plus 2. And when we go ahead and solve that out, we're going to get 3/2. So our answer here is A equals 11 and B equals 3/2. All right, so here's your assignment. We're on page 495. We're doing 11 through 45 odd. You can go ahead and skip 29. Let us know if you have any questions on this. Hopefully it goes okay for you guys. Enjoy your day off tomorrow. You get a little bit of a long weekend. Hopefully you can get outside, do something fun, but don't forget to do your homework. See you guys.